In this video, we're going to look at whether or not these two triangles that are different sizes are similar. So we're really looking at are the sides of the triangle proportional to one another? That's another way to think about it. And so what we first have to do is we have to look at these triangles and make sure that we're matching up the sides that are corresponding to one another. So for instance, I'm just going to give you an example. When I'm looking at this triangle, I see that I have this very long side of my triangle. In other words, this is the longest side of my triangle. Just going to highlight it. And I want to go to the second triangle and find the longest side of this triangle. And I notice that this side appears to be the longest side. And then I want to go ahead and find one more side, because if we're going to determine if it's similar, we're going to have to set up a proportion. And we need to check at least two sides of the triangle. And if two sides are proportional, then the third will be as well. So for instance, I can check this next one here. Notice this is the smallest side of my triangle, so I'm going to pick it because that's easy to identify. I'm just going to look for the smallest number on this other triangle that looks larger. And the smallest number over here is 9. So I've highlighted the sides that have a relationship to each other. In other words, JK has a relationship to IH. So now I'm going to set a proportion up using these two sides that I've located that have a relationship. Now when I set that up, I'm going to go ahead and put my fraction bar equals another fraction bar. And what I want to do is I want to make sure when I set up this proportion that I'm very careful about how I do so, because it needs to be set up a certain way. I'm going to say that this right here is my first shape, and I'm going to write right here first. So all the first shape values are going to go inside the numerator right here. And then I'm going to go ahead and call this my second shape. Alright, now for my first shape, notice I'm going to go ahead and do my largest side first. So I'm going to do this 8 value, right, representing that pink line, the longest side of my shape. And I'm going to put 8 right here. And then the side of the second triangle that matches up with this first one's value of 8, right, the longest side, is going to be this longest side, which is 24, so the LJ. And so I'm going to write 24 in the denominator, because these two have a relationship with one another, right? These are both the longest, I'm going to put right here, longest side of my triangles. And now I'm going to go ahead and I'm going to go to the next side of this first one, the shortest side, right? And that was 3. It's this one highlighted in yellow, so I'm going to put a 3 right there. And now I need to find the shortest side of the second triangle. So this shortest side right here is this one that you can see, this JK, and that's going to be 9. So notice all my values for my second shape are in the denominator. All the values for my first shape are in the numerator. This right here is my 3 and 9 are my yellow highlighted sides, and my 8 and 24 are the pink highlighted sides. And what I'm going to do now is cross multiply. And if these are similar, in other words, the sides are proportional to one another, then what's going to happen is I'll end up having the same value on both sides of the equal sign when I cross multiply. In other words, this is 24 times 3. I'm cross multiplying. Now I'm going to write it out just so you can see what's actually happened. Is I'm doing 24 times this value of 3. And I'm going to have that set equal to these two values that I'm going to cross multiply. So I'll have 8 being multiplied to 9. And when I multiply these values out, when I get their answer, if they are both the same, if I have the same value, then they are going to be similar. And I'm going to go ahead and do 24 times 3. And when I multiply that out, that gives me 72. And then I'm going to do 8 times 9. And notice that also gives me 72. Now notice this makes a true statement. This is true. 72 is equal to 72. And by me setting up this proportion with sides that have a relationship with one another from two different shapes, it proves that these are similar triangles. Well, this is part of my explanation, is me proving that it's proportional. And I'm going to put on here triangle GIH is similar to triangle LJK.